The Grand Staircase by Zachary Lundgren. What is the Grand Staircase? The Grand Staircase is an immense sequence of sedimentary rock layers spread throughout the American Southwest, ranging in age from less than 60 million all the way to 1.2 billion years old. Created over hundreds of millions of years, the Grand Staircase is perhaps one of the Earth's greatest history books. Formed from deposited material lithified into stone, we could get a glimpse of what our world was like in the planet's distant past. What happened to create the Grand Staircase? To recap, the Grand Staircase is a term used to describe a massive sequence of individually distinct rock layers. Over hundreds of millions of years, each of these layers were individually deposited and lithified into rock. Note, there are contradictory opinions on which layers are included as part of the Grand Staircase. Some lists may conclude with the Kaibab limestone, which marks the rim of the Grand Canyon. Others will stop at or around the igneous Vishnu schist, which marks the base of the Grand Canyon. Don't worry, I will clarify all these terms in detail later on. Now, a small lesson on the types of rocks found in the Grand Staircase. First off, nearly everything in the Grand Staircase is sedimentary. This means that the rocks were formed and lithified or compacted from deposited sediments. The major two types of sedimentary rocks are sandstone and limestone. Sandstone is formed from, as the name implies, sand. However, limestone, hence the name, is not composed of limes and other various prehistoric citrus fruits. Limestone is formed from calcium carbonate. This is a scientific term for bones and other dead things. Most of the time, limestone is formed from the shells and bones of deceased sea creatures. Other honorable mentions. Number 1, shale, mudstone, and siltstone. These soft and brittle rocks are often composed of, once again hence the names, mud, silt, and other deposits. These rocks are laid down during times of more abundant water. This can include swamps, marshes, or just a lush rainforest. Number 2, last but not least, we have igneous rocks. This is a type of rock which is formed from the solidification or crystallization of magma. Apart from Vishnu schist, igneous rocks are mostly found in isolated pockets where volcanic activity occurred in the past. Layers above the Navajo sandstone. Although there are many layers of rock above the Navajo sandstone, it is generally considered to be the highest meaningful layer of the Grand Staircase. Now, for honorable mentions, above the Navajo sandstone layer, we are presented the Pink Cliffs, Gray Cliffs, and White Cliffs. The Pink Cliffs feature the Claren Formation and Cannon Peak Formation. The Gray Cliffs have the Kaparowitz Formation, Wahweap Formation, Straight Cliffs Formation, Tropic Shale, and Dakota Formation. Below, the White Cliffs feature the Carmel and Entrada Formations and the Temple Cap Sandstone. Now onto the Navajo Sandstone. Navajo Sandstone. At over 2,000 feet thick, Navajo Sandstone is one of the largest and most famous layers of rock featured in the Grand Staircase. This layer of sandstone was laid down and lithified roughly 190 million years ago during the late Triassic and early Jurassic periods. This means that when this rock was laid down, dinosaurs were still around and blissfully unaware of their impending doom. Navajo sandstone can also be seen in 4 separate states: Utah, Nevada, Arizona, and Colorado. Part 2. Along with the Kayenta Formation below, Navajo sandstone is part of the larger Glen Canyon group. This group also consists of the Wingate and Moenavi formations. Due to its immense size, Navajo sandstone is often seen in the form of steep cliffs with a maximum height of 2,000 feet. Above the cliffs, the sandstone can be observed in the form of massive bluffs or domes, generally pale white in color. The Kayenta Formation. Another member of the Glen Canyon group, the Kayenta Formation is a geologic formation consisting of sandstone. The layer is also generally around 400 feet thick. The Kayenta Formation is believed to have been formed around 180 million years ago. This formation is especially prominent in southeast Utah and ranges from red to dark brown in color. The Moenavi Formation. The Moenavi Formation is a layer of the Grand Staircase consisting of siltstone and mudstone. This layer is generally only around 75 to 100 feet thick and is believed to be between 195 and 210 million years old. The Moenavi Formation is believed to have been deposited in numerous riverbed, lakebed, and floodplain environments. The Wingate Formation. Deposited from immense sand dunes roughly 200 million years ago, the Wingate Formation is found below the Navajo and Kayenta layers. The Wingate Formation usually ranges from pale orange to red in color. Along with the Moenavi Formation above, the Wingate Formation is once again a member of the Glen Canyon group. The Chinle Formation. The Chinle Formation is a layer of sedimentary rock mainly consisting of mudstone, siltstone, and sandstone. With a maximum thickness of roughly 1,700 feet, the Chinle Formation dates back to between 210 and 225 million years ago, during the late Triassic period. Kaibab Limestone. The Kaibab Formation. The Kaibab Limestone is a geologic layer of the Grand Staircase visible across the states of Arizona, Utah, Nevada, and all the way into California. This layer of limestone is also most famous for marking the rim of the titanic Grand Canyon itself. The Kaibab Limestone was laid down roughly 270 million years ago during the Permian period. This layer is around 300 feet thick in the Grand Canyon region and overall has a maximum thickness of 1,000 feet. The Toroidal Formation. At around 273 million years old, the Toroidal Formation is a relatively thin geologic layer positioned between the Kaibab Limestone and Coconino Sandstone. This layer is mainly composed of sandstone, siltstone, and gypsum-rich shale. Overall, the Toroidal Formation has an average thickness of 200 feet and is yellow-gray in color. Coconino Sandstone. Particularly prominent in the Grand Canyon, Coconino Sandstone dates all the way back to the Permian period, roughly 275 million years ago. Although it could be only 65 feet thick, Coconino Sandstone can reach a thickness of over 600 feet. It is especially prominent in the Grand Canyon Village area. This layer is generally white in color. Hermit Shale. The Hermit Formation, or Hermit Shale, is a loose layer of siltstone, mudstone, and fine-grained sandstone dating back to 280 million years ago. The non-resistant layer is generally colored reddish-brown. Due to being non-resistant, Hermit Shale often forms loose slopes. The Supai Group. Dating from 285 to 315 million years ago, the Supai Group is a series of sedimentary rock layers at most 1,000 feet thick. These rocks are predominantly composed of sandstone, mudstone, limestone, and some amounts of dolomite. The Supai Group is known for its vibrant rust-red coloring. The Surprise Canyon Formation. The Surprise Canyon Formation is a layer of the Grand Staircase consisting of clastic sedimentary rocks such as conglomerate. For some context, clastic means that the rock is formed from fragments of pre-existing rocks. This rock layer is 320 million years old and is reddish-brown in color. Redwall Limestone. Redwall Limestone. Perhaps one of the most easily spotted layers of rock in the Grand Canyon, the massive Redwall Limestone gives the Grand Canyon its world-renowned rust-red coloration. Due to this layer of limestone being ultra-resistant to erosion, Redwall Limestone often forms large cliffs. Ranging in thickness from 500 to 800 feet, Redwall Limestone is on average 335 million years old. Fun fact, this layer is not actually red. The Redwall Limestone is in fact naturally gray in color. The limestone is stained red by iron oxide from the iron-rich layers found above. Temple Butte Limestone. At 385 million years old, Temple Butte Limestone is at most only 100 feet thick. This layer of limestone is reddish-purple in color and often merges with the Redwall Limestone cliffs above. Muav Limestone. Below the visible Redwall Limestone and the inconspicuous Temple Butte Limestone, the Muav Limestone dates back to 505 million years ago. At most, this layer is around 605 feet thick and is generally light gray and/or orange in color. The Bright Angel Shale. A member of the Tonto group, Bright Angel Shale sits right upon the massive Great Unconformity. This loose layer dates back to 515 million years ago and is known for composing the surface of the immense Tonto Plateau. This layer is made of shale and some loose pockets of sandstone. Bright Angel Shale is green and occasionally purple-red in color. The Tapete Sandstone. At around 230 feet thick, this ultra-resistant layer of sandstone is an ancient 525 million years old. Tapete sandstone provides a significant amount of the structure for the Tonto Plateau found above. This layer is usually colored from gray to reddish-brown. The Grand Canyon Supergroup. Dating from 650 million to 1.2 billion years in age, the Grand Canyon Supergroup is a massive independent sequence of sedimentary layers. Compared to every other layer of the Grand Staircase, which are horizontally parallel to one another, the Grand Canyon Supergroup is in fact tilted. Due to this feature, the grouping of layers are only partially exposed in the eastern part of the Grand Canyon. Vishnu Schist. Vishnu Schist. Also known as the Vishnu Basement Rocks or the Vishnu Metamorphic Complex, Vishnu Schist is a layer of igneous rocks dating back to 1.7 billion years ago. This layer marks both the bottom of the Grand Canyon and the base of the Grand Staircase itself. A repeating cycle. Upon looking closely at the Grand Staircase, you might have noticed a repeating cycle of rock types. This cycle is dry, moist, wet, moist, dry, etc. This cycle can be geologically translated to sandstone, shale mudstone, limestone, shale mudstone, and then back to sandstone. You see, this is all due to changing climates. Part 2. Having been laid down and lithified over the course of hundreds of millions of years, the Grand Staircase has seen a pretty diverse range of climates. When the sandstone layer was laid down, the region was an immense desert topped with endless fields of sand dunes. The region might have ranged from a swamp to a lush forest when mudstones and shale were laid down. When limestone was deposited, the region might have been completely submerged by an ocean or sea. Uplift. Tectonic uplift is one of the major factors in the formation of the Grand Canyon. This is especially visible in the Kaibab Plateau. Seen from afar, the region might resemble a massive, gentle dome. Even though the layers of rock in the Grand Canyon are below the other layers found in the Grand Staircase, the Grand Canyon is actually at a higher elevation. This is all due to uplift. When the region was uplifted in the distant past, it allowed the Colorado River to erode away a path through it. This process eventually formed the Grand Canyon we see today. How erosion affected the Grand Staircase. Today, the Grand Staircase can be marveled at through a plethora of unique and well-defined rock formations and canyons. This is all due to erosion. When the entire region was uplifted long ago, rivers soon became trapped in the canyons which were eroded out of the rock. With nowhere to go, the water continued to erode away the layers, eventually forming the massive canyons we see today. Last but not least, the Great Unconformity. The Grand Staircase is a great way to measure the geologic history of our planet. However, deep inside the Grand Canyon, almost 1.2 billion years are missing. This is found between the Tapete Sandstone and the Vishnu Metamorphic Complex. Here, we bring back the Grand Canyon Supergroup. You see, the supergroup was tilted upwards long ago, but somehow eroded away. Present day, the top of the Grand Canyon Supergroup is sheared right off, replaced by the horizontal layers of the Grand Staircase found above. Due to this, the Grand Canyon Supergroup is only visible in select locations. Of course, there must be a reason why a billion years of geologic history was suddenly eroded away. The reason is a theory known as Snowball Earth. The theory states that hundreds of millions of years ago, the Earth was covered by glaciers. Through glacial erosion, a billion years of rock was eroded away. Thank you for watching.